Hi, I'm Travis and I'm going to explain to you standard deviation. Number one, what is it? Standard deviation is how much each data deviates or how far away each data is from the mean. On an average, how far away your data is from the mean. And its formula is pretty confusing. But still, I'm going to explain this, make it more confusing for you, and then explain it again. Awesome. Now, I have data 60, 61, 65, 63, 98, 99, 90, 95, 91, 96. 10 of these. And I'm going to estimate their mean looks like about 83. It looks like 83. That means on an average, each one of them deviates by about 17, 18, I can say, at a guess. Now, to explain the code, you import the library math and you import the library CSV. Now, if I open standard deviation.csv and I make the new line, it's just like you to read the data. Now, these four lines is to read the data and make it a list. Open it, read it, make it a list, and then make this variable another variable's name, just changing the name of the variable sort of thing. Now, let's come to the new part or the main part, I can say. If I make a function called mean and use data as its main variable, n will be the length of data, and for every x, the total will be total plus x. Mean will be total divided by n, and you would return mean. This was done in the previous video of mean, median, and mode in Python. Now I create something a list called squared list. What I have to do now is for every number, it's pretty simple. It's for every number in the data you have, a will be the number minus the mean. Now, whatever you get, you square it. And that is what you append or add inside square list. And you will get 10 such values. Now you create a new variable called sum, which is 0, static initialization. Then for any variable I in the squared list, sum equals sum plus I. That means you're finding the sum of all the numbers, sum of all the A's in squared list. After that, the result will be the sum divided by the length of your data minus 1. Now I have 10 here, it could be 50,000, but I have to minus 1 and I have to divide the sum by that number. Finally, standard deviation itself will be the square root of your result. Now to actually see its result, boom, 17.09. I was close, I was close. It's actually pretty, you can do this, mentally because I could estimate it's around 80 and then naturally each one of them would deviate by about 16, 17 or 18. So that's standard deviation for you guys. I hope you understood. Next topic, please. All right, for the next one, correlation. What is it? The relationship between two data sets. No set formula per se, but if I see this, the size of the TV in inches or whatever you want to say, and the average time spent watching TV in a week in hours. I have a 12-inch TV. The laptop is bigger than this one. Still, this is the data I'm given. The size of TV is 12 inches, and people can spend 36 hours in a week watching it. And you see very consistently on a majority, the higher the data set, the higher the size of the TV, there are more number of hours spent watching it. So that's exactly what we're going to confirm. If I see, I import something called plotly.express. It is the graph that opens the graph. Then if I import CSV and I import numpy, it's not grumpy, it's numpy as NP. NumPy does mainly all your mathematical stuff related to correlation, standard deviation, single sample z-test, normal distribution, all that. Now, if I get that to give the data source, you operate with something called the data path. There will be something called a size, there will be something called watch. So size of the TV and number of hours watched. So when you open this data path as F, you will read it like a dictionary, dict reader F. So it will read and save it like a dictionary. And then for a row in this CSV reader, you will append the row size of TV and you will append the row average time watching TV in a week in hours. It's just like saying for this, for one row, what you do is the size of the TV, what one data, put it inside size, and then the number of hours spent in a week watching TV, put that in another, and keep doing that till the number of rows get over. And then you return X variable size and Y variable watch. And now when you finally find a correlation, it will be something called data source. Using the data source, you make a function called find correlation. The correlation will be numpy dot CORRCOEF, correlation coefficient. Using X and Y, it will do the mathematics and you should be done that way. Then you print the correlation between the size of the TV versus the average time spent watching TV in a week in hours is the correlation of 0 and 1. Now you can finally create a setup where, in case you're wondering what is data path, what is data source, you have not given that. Why have you not given that? Many of you coders will be screaming at me, but here you are. The data path is TV size 1.csv. The data source is the data source from the data path, and the correlation will be the data source. Now, what this ensured is you don't have to actually give your data source. You don't have to actually call all these functions. You call up one function and it helps. This, you currently see two functions that I'm combining in one. There can be multiple, in a multiplayer car racing game which is built properly, not like mine. I could have also shown the graph, but well, it's a little confusing to explain, so I would not explore that direction. Now, I have explained the main code. Similarly, when I see school, now what is school? What is school? School is the marks in percentage and the days present. That means the number of days present. 1 minute. The number of days present, and then naturally the marks in percentage. And well, yeah, that also naturally, if you're present more in school, there might be a higher chance of you even passing. Now let's see this. Junk food 1. Ice cream. Ice cream and cold drink sales. Now, what is this? According to the temperature, what is the ice cream sale and what is the cold drink sale? Now we know the temperature is high, there will be more sales of ice cream and more sales of cold drink. Similar code here, exact same code here. Now we have something called coffee sleep. It's different. Coffee sleep. If I have more coffee, will I sleep more? No, I'll sleep less. So if I drink 20 ml of coffee, I'll see how much 20 ml of coffee in a day. I'll see how much sleep I get in hours in a week. This data really looks inaccurate, but it is the best data that can show you. This is the only one that's inverse. Now, if I were to run my code here, py, I have to run everything. Py coffee sleep dot py. Let's run this. There you have it. Minus 0.963061, whatever. Now, next one. Py ice cream dot py. This is 0.95. Now I will say py school1 dot csv. Whoa. Dot py 0.86, and then py pp size 1 dot py. There you have it. Two of these are in negative. Including these two. So what I had said about this was actually wrong. The bigger your size of the TV, less hours you will spend watching it for some reason. Anyway, that's the data given to us. This teaches us two things. It teaches us correlation, and it also teaches us why too much coffee and too much TV is bad. Well then, this is it for the video. This was correlation. If you have any doubts, please drop it in the comments. I will answer them. Stay safe, everybody. Bye.